Let's talk about lines. Let's start talking about lines. Let's talk about the slope of a line. In a previous video, we did this filling out a table thing where we took some x values and we plugged them into a function y equals something, and then we had coordinate points and we plotted those coordinate points to make a line. Let's do that again. Let's plot some points. Let's take some x values, plug them into a function, get some coordinate points out. So for this first one, I'm plugging in -2 for x. So we have 2 times -2 for x minus 4. That'll be -4 minus 4, which is -8. So this is the coordinate point -2, -8. -2, -8. Plugging in -1 for x. We get -2 minus 4, which is -6. -1, -6. I'm going to pause the video while I fill in the remainder of this table because I know you don't want to hear me do it out loud that entire time. So give me a sec. All right, so there we go. I have the rest of my table filled out. I haven't plotted these points yet though, but I got -4, so 0, -4, 1, -2, and 2, 0. Just plugging these x values into this function here. So plotting those remaining points, we have 0, -4, 1, -2, and 2, 0. And if you see, if I just extend that line out, if I connect the dots and extend it, I have indeed created a line. Now, notice that every time the x value goes up by 1, right, from here to here, we've gone up by 1, up by 1, up by 1 each time. Notice that the y values go up by 2. Every time the x values go up by 1, the y values are going up by 2. We say that the slope of the line is 2 because every time the x value increases by 1, the y value changes by 2. We call that the slope of a line. I'm going to write that down. So let's say the slope of the line is 2. Let's do it again down here with a different function, right? So this is -1/2 x plus 1. I'm going to plug in these x values, get myself some coordinate points out. So -1/2 times -2 plus 1. That's going to be 1 plus 1, or 1 plus 1, which is 2. This is the point -2, comma 2. I'm going to fill out the rest of this table while paused. All right. So I have filled out the rest of my table. I have the y values 2, 1.5, 1, 0.5, and 0. With these y values, notice that they go down by 1/2 each time x increases by 1. So x goes up by 1, and the y value goes down by 1/2. That means that our slope is -1/2 because each time x increases by 1, the slope goes down by 1/2. That means that the slope of this line is -1/2. The slope represents the change in how much y changes every time x changes by 1. How much is our y value changing every time we increase x? Let me plot these points real quick. So we have -2, 2. We have -1, 1.5, 0, 1, 1.5, and 2, 0. Let's see if let me drag that. Good enough. There we go. So the slope of this line up here is 2, is 2. Every time we increase x by 1, we go up 2 in our y value. Slope over here, go down or go over 1, we go down 1/2. In general, we say that the slope of a line is equal to the rise over the run. Rise over run. This is probably something you've heard before. Slope is rise over run. And what that really means is that the slope is the change in y values over the change in x values. Boop, boop, boop. So if I have a line here, and let's say that going from this point here to this point here required me going up 2 units. Let's say this was up 2 units and over 3 units, this hypothetical line. We would say that the rise is 2 and the run is 3. So for this line, the slope would be the rise over the run, which would be 2 over 3. So the slope of this line would be 2/3. If getting from one point to another required going up 2 over 3, the slope would then be 2/3. Let's look back at these other lines we were looking at. I can choose any point on here, right? I can choose any point. So if I start here at this point, this is the point, well, it's -1, -6. And let's take another point here. This is going to be like a really big difference. So to get from this point to this point, we had to go up. See, this is 6 units here. This is another 6. We had to go up 12 units. And we had to go to the right, 1 plus 5, so 6 units. So the slope, the run, the rise is 12, the run is 6. Rise over run, 12 over 6, that simplifies down to 2, which is what we said the slope was. Okay. And I can do this, like I said, for any pair of points on this line. Here, to get from this point to this point, we're going up 4 units. We're going to the right 2 units. Rise is 4, run is 2, slope is 2. This is going to be consistent no matter what 2 points we choose. We can do that same thing down here. Right? I can take, let's say, oh, it would help if this line was plotted more perfectly. Let's see. There we go. That's a little bit better. So here we went down 2 units and we went to the left or to the right 4 units. So our rise was -2, our run was 4. That simplifies down to -1/2. I could go from this point to this point. I go down 1, I go to the right 2. That's -1/2. The slope is -1/2. Any 2 points you choose on there, if you take the rise and put it over the run, it will simplify down to -1/2. There's some important notes that you need to keep in mind when finding the slope of a line visually from a graph. One, always start with the leftmost point. This is one where it's not technically a math rule. It's just this is how I teach it. Okay, hold on just a. All right. I just got distracted by something, so I'm coming back to this recording after about a 10 or 20-minute break here. Last, you heard me talk. We said that when we're finding the slope, we always start with the leftmost point. You don't have to start with the leftmost point. I suggest it and I teach it this way because it's a nice rule to go by and it makes it very consistent. But if you go online and look at how other people do it, some people might not start with the leftmost point. That doesn't mean they're incorrect. That's just not how I teach it. All right. 2, as long as you start with the leftmost point, your run will always be a positive number. And 3, your rise is going to be negative if you go down and positive if you move up. So let's look at some lines that are on grids and let's find these slopes just based on the grid. So we are starting here at this point. Our rise, this is our leftmost point, our rise to get to this point here, we're going to have to go down 4 units. Go down 4 units. And then our run is to the left 5 units. So our slope, rise over run, -4 divided by 5. Okay. We had to go down. That's why our rise is negative. Our run will always be a positive number. For this next point set, starting with the left point, we have to go up 3 units. So our rise is 3. And to the right 2 units. So our run is 2. So our slope is 3/2, rise over run. In this last example, starting with the left point, we need to go down 4 units. So -4 for our run, and to the left or to the right 2. So -4 divided by 2, that simplifies to -2. So the slope of this line is -2. So that's one way to find slope if you have the line already graphed. But there's other ways that we can find the slope of a line. For instance, if we have 2 points on a line, we have the coordinate points of 2 points, we can find the slope between them without graphing. We have a formula. I'm going to draw, maybe not a line, maybe I'll just draw my points here. So I have a point here and I'll have a point here. I'm going to call this generically x1, y1, and this point up here, x2, y2. We said that slope is equal to rise over run. We said that that was the same thing as change in y values over change in x values. So if I want to find the change in y values here, I want to find the change in y values, right across here, this value must be y1. This value up here would be y2. And we want to know this direct distance upward, this distance right here. If we take the bigger number, y2 minus y1, that will give me the change in y values. So y2 minus y1 is the change in y values. To find the change in x values, right here, this is x1. Over here, this is x2. The distance between x1 and x2 would be x2 minus x1. The bigger number minus that smaller number there. And that is our change in x values. So that's what our slope formula ends up looking like. If you have 2 points, x1 and y1, x1, y1, and x2, y2, then you can use the formula slope is equal to y2 minus y1 over x2 minus x1. Let's do a small example of that. We're given 2 points, 5, 2, and 4, -3, and we want to find the slope between these 2 points. I'm going to call this guy x1, so x1 will be 5. y1, which maybe I'll do in pink, y1 is 2. This will be my second set of points. x2 is 4. y2 is -3. It does not matter which set is x1, y1, and which one is x2, y2, as long as you're not mix and matching the 1 and 2s between a single coordinate point. So it would be fine if I said this one's x2 and this is y2, but it wouldn't be fine if I said this is x1, this is y2. They have to both be the same subscript. My formula for slope, y2 minus y1 over x2 minus x1. So y2 is -3 minus y1 is 2. On the bottom, x2 is 4 minus x1 is 5. -3 minus 2 is -5. 4 minus 5 is -1. -5 divided by -1 is +5. So the slope of the line containing these 2 points would be 5. So no matter how we're doing it, if we have 2 points, we can find the slope of a line. We can do it by graphing if we have a graph, like we did up here. Or if we don't have a graph and we just have those 2 points in front of us, we can use this slope formula to do it algebraically. All right, so we're going to take this idea of a slope and we're going to do stuff with it, but in another video. So for now, I hope your day is wonderful and full of joy. I will see you in another video. Goodbye.